Okay, so yesterday we talked about law of sines, right? So we're going to do a little bit of review of what we did yesterday, and then we're going to talk about what's called the ambiguous case. All right, so we've got example 7 up on the board. I want you to go ahead and use law of sines to find the missing angle that they'd like, okay? It says in triangle HIJ, shown below, it is known that IJ is 12. Sean, go away. Go away. Nope, I told you one chance. IJ is 12, HJ is 26, and the measure of angle H is 25. Determine all possible values for the measure of angle I to the nearest tenth of a degree. Okay, so I want you to use law of sines just like we did yesterday. And let's see if you can find angle I. Someone tell me how they set up their proportion. Over sine of 25. Yeah. Sine I. Good. Please don't pick and choose your variables. You got to use what's there. Okay. Okay. Now what? Sure. What did you get when you cross multiplied? Okay. Good. Okay. Now what? Good. All right. Now what? Enter what into your calculator? Yes. Good. I want to take the inverse. Okay. What does I represent? An angle. How do I find angles? Good. So what you're going to put in your calculator is sine inverse of this. Go ahead, do it. I'm not doing it for you. Not yet. I'm making everybody type it in. How does it want it rounded? Nearest tenth. What did you get? 66.3 degrees. Tell me why I used this symbol. Why is it an approximation? It's decimal. It's rounded. Okay, so make sure that you're using the correct signs there. Okay, symbols. How did we do? Good reminder from yesterday? Okay. Let's take a look at the next one. Okay, so in the diagram shown below, it is given that points B, C, and D are collinear. What does collinear mean? On the same line. It is also known that the measure of angle D is 20, the measure of angle ACD is 115, and the measure of angle B is 90, and CD is 18. Determine the length of AB to the nearest tenth. So here's what I want you to do. I want you to redraw this into your notebook. I want you to read the problem again, and I want you to label everything that you can possibly label. Okay? Find anything missing that you can possibly find without having to do anything fancy. Okay? And then we'll talk about how we find that missing side. You should have found all your missing angles by now, right? What did you get for angle CAD? 45. Okay. What did you get for angle BCA? 65. Good. How did you get that? Supplementary angles. Very good. Okay. What did you get for BAC? 25. And what did you get for BAD? BAD. Yeah. Yeah. Can you do that? No. Okay, so you got all your missing angles, right? I also made note that CD was 18. That was given in the problem, correct? What is it that we're looking for? AB. Let's call it X. All right, so usually we've been using log signs, right? What do you need to have if you're looking for a side? If you're using log signs, what do you have to have? And you have to have an opposite angle, which do you have that? Sure. What else do you have to have? Another side and another angle. Do I have another side in that triangle? No. Okay, so I can't find this yet. It's going to have to be kind of a two-step problem. So let's think about what we do have, or what we would like. We want another side, right? What other side would be nice to have? AC would be nice to have. Yeah. If I had AC, this side here, would I be able to find X? Sure, because then I would have an angle, or an angle and a side, and I would have a side and an angle, opposites, right? So I want AC, we'll call it Y. You okay with that? All right. Can I find Y with the information I have? Sure. Okay, Y, how do you know that? I have angle, can't call it A. CAD, I have angle CAD, and I have its opposite or corresponding side, right? So I have this and this, corresponding side and angle. I want this side, I have its corresponding angle. Okay, so we have to find Y before we can find X. Okay, so go ahead, use log signs, find me Y, and then we'll go from there. Okay, who wants to set it up for me? Don't everybody jump at once. Mm-hmm. Good. 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 How many people set it up correctly? Awesome. Now what? Yeah. So y sine 45 equals 18 sine of 20. Now what? Mm-hmm. What'd you get? Okay, now, here's an issue. What is it that we're actually solving for? We're solving for X. So, Y, I want to be as exact as possible. I don't want it to be a rounded value. I want it to be as exact as possible. Do you agree? So am I going to round Y to the nearest tenth? No, I'm going to put as many decimals as I can, and I'm going to use that to find X, because that's the one that we actually want to find and round. Okay? So you got what? Okay, that's better. Okay? So you do not round until the very end, all right, guys? So now we've got Y, and notice I still have approximately, right? It's still approximately, and it should be because it's still rounded. It's just done for us, decimal. Now we want to go and find X. So who wants to set that one up for me? Somebody else. X over sine of 65, good. Mm-hmm. Not Y. We found the value of Y, remember? Okay. Sine of 90. Good. What's sine of 90, guys? 1. Remember when I told you guys you had to memorize the trig values? Yeah, I wasn't kidding. Notice we're still using them a lot. You have to have them memorized. Now what? Yeah, we said sine of 90 was what? 1. What's 1 times x? X. So we get x equals 8.70641 sine of 65. Okay. Good. Find me my answer. Round it to the nearest tenth. Why did I do what? Be a little more specific, dear. 1 times x is just going to be x. Yeah, absolutely. Yeah, if you divided this whole thing by sine of 90, it would be the same. Okay, what do we get to the nearest tenth? To the nearest tenth, 7.9. Good. Okay, so we're going to get a lot of these two-step application problems. Was it hard? It's just figuring out where you have to start, right? So you always start by filling in as much information as you can get. Okay. So now let's talk about the ambiguous case. Okay. So there's going to be times where we have to solve a trig equation in order to determine an angle of a given triangle. We just did one of those. We had to take the inverse and find the angle. What's going to wind up happening is we're going to wind up with a possibility of more than one solution for an angle. Okay? We call this the ambiguous case. If we think about it, when we're solving for an angle, let's say I said sine theta equals 1/2, right? How many places can sine be equal to a half? 2. Where? Yeah. Okay, so we always went back and we looked for that second possible solution, right? Well, the same thing's going to happen with triangles. How many degrees in a triangle? 180, right? So we're going first, not 3/6, that's a circle. We're going first and second quadrant. So there's a possibility of getting an angle in that second quadrant, an obtuse angle. We have obtuse triangles, right? They're not all acute. So we do have a possibility of that second angle. Okay? Now, you do have to make sure that your second angle actually would make sense or is realistic, but we can definitely get one and check for that. Okay, so in triangle ABC, that's shown below, AC is 10, AB is 14, and the measure of angle C is 80. Solve the equation to find all possible values for the measure of B to the nearest tenth. Okay, so you guys know how to find angle B using law of sines. You've done this. You also know how to find the second angle, right? If it's in the first quadrant, you know how to find it in the second quadrant, 180 minus theta. Okay, so I want you to go ahead and I want you to find both of those solutions, and then we'll talk about how we check for whether or not it's realistic to have both. All right, so go ahead. Okay, tell me what to set up, guys. How? Good. Okay. Okay. Good. Equal? Okay. And what do you get? Okay. How many of you got all that? Awesome. Now, here's the thing. I have to make sure that 44.7 and 135.3 degrees both work as possibilities for a triangle. Okay? I've got 80 degrees here, don't I? So I already know one of the angles is 80 degrees. How many degrees in a triangle again? 180. All right, so here's what you do. 44.7 plus the angle that I know, which is 80. What does that give me? $124.7? Yeah. Huh? So do I have room for a third angle? with that? Sure. So that one checks. Okay. So I got to take my other one, the 135.3, and add 80 to that. What does that give me? Doesn't give you 180. So, do you have room for a third angle? What's happened? No, it's not an obtuse. I've exceeded, right? Can I have this happen? No, so this actually gets rejected. Why? It's not a possibility, right? So my only answer is going to be 44.7 degrees. So what you're going to get from this is one distinct triangle. Okay? You have the possibility of having one or two distinct triangles. 1, 2, or 0. Okay? Never more than 2 distinct triangles because you're talking about the first and second quadrant. Okay? So they may ask you how many distinct triangles. You're going to do log signs and figure out how many work. In this case, we have one that works. Okay? I guess I would do that, or you could put it in brackets. Okay? All right, so that's the ambiguous case. That's what that means. So let's look at another one. Got to answer the question. Okay, so considering that the measures of any triangle must add up to 180 degrees, why do we have to reject the obtuse solution? Or it's not possible. It exceeded the allowed number of degrees in a triangle. Okay, so again, we call it ambiguous because it is positive for all angles on the interval from 0 to 180. In most sine equations, 2 values will be possible. An acute solution and an obtuse solution, but as you saw, both solutions may not be realistic, so we may have to reject. Okay, so in triangle ABC shown below, it is known that AC is 6, AB is 10, measure of angle B is 36. You're going to determine all of the possible solutions for the measure of angle C to the nearest tenth. So go ahead and do exactly what we did.